Dear students, in continuation of this Unit 1, the last two videos which you have seen about the Unit 1 about the electronic components, and there you have understood about the importance of the components, its function, and the AC signal, and what is DC signal, and how to analyze the circuits using Kirchhoff's law, Ohm's law, and also about how to apply the network theorems for a complex circuit and what are the different types of network theorems are available to analyze the circuits about its voltage and current and all that. And coming to this unit 2, this unit is the most important unit. And the present technology, the what we call it is a IC technology, or everything we talk about the digital electronics, or digital field, or we talk about internet, or we talk about information technology, or we also talk about the latest electronic gadgets, mobile, high-end mobiles, high-end computers. This entire thing, whatever we are having at present term or the now or the present technology is about this semiconductors. This unit, in this unit you are going to study about what are the semiconductors, what are the materials used in semiconductors, what are its properties, what are its characteristics, and how we can use. You see, after the Second World War, please remember, till the Second World War, the electronics was not that much has grown. But after the Second World War, when the transistor was invented in the Bell Laboratory, USA, there is an exponential increase in the technology. You might have heard about, or you might have know about that in the earlier in the last beginning of the last century, we were used about the vacuum devices and all. Then after the Second World War, after 1945, when the transistors was invented, there was a revolution in the field of electronics. There was an evolution. Then those days we considered, which was very bulky, very big devices. Now gradually they have reduces into the size has reduced, size, storage capacity, even the storage capacity has increased now. So this is all about due to the what about the discovery of the two materials which mainly used in the semiconductor. So this unit is about a semiconductor, and here we are going to just about the importance of the semiconductor. And please remember, the present devices or the components which we use nowadays are all based on this semiconductor materials. Coming to, and again, you are knowing about what are the materials used in semiconductor. See, immediately the most of the students will say, yes, the semiconductor materials are silicon and germanium. Not only silicon and germanium, but there are other materials which exhibit the property of the semiconductor. Because normally when we ask how to define a semiconductor, and it is very difficult to define. For example, a conductor, we can say conductors are those substances which allows the current to flow through it, whereas an insulator are those substances which does not allow the current to flow through it. Example of a conductor, we can say copper, aluminum, all that. Example of an insulator, we can say wood, rubber, glass. But how to define a semiconductor? So semiconductor to define, there are many ways of defining it is there. And the one way we can say is that semiconductor materials are exhibiting the characteristics are that, it has a resistivity less than an insulator, more than a conductor. Okay, so that is also you are going to study about in this unit. Then how the semiconductor materials are prepared, formation of semiconductors. So then what is doping? Because, you know, when the pure semiconductor is actually an insulator. The pure semiconductor is an insulator, which has the property of an insulator, but that property we do not want. So when we add something to it, so adding impurities to the semiconductor material, we call it as doping. But when you add some material into it, then the entire semiconductor property has been changed. Then it starts behaving as a semiconductor. So that is also you are going to study about it, and the importance of trivalent and pentavalent impurities, because based on these trivalent and pentavalent impurities, we have two types of semiconductor: N-type semiconductor and P-type semiconductor. An N-type semiconductor is a semiconductor where when a pentavalent impurities is added to the pure semiconductor, then there is an excess of electrons in the semiconductor. When trivalent impurity is added to pure semiconductor, then there is a deficiency of electron, that is called holes. So in N-type semiconductor, electrons will increase. In P-type semiconductor, holes will decrease. Here you please remember, semiconductor has two carriers, electrons and holes. And it has majority carrier and minority carrier. In N-type semiconductors, we can say majority carriers are electrons, minority carriers are holes. In P-type semiconductors, we can say majority carriers are holes and minority carriers are electrons. So that is also about this. And once you form this P and N, then the semiconductor devices are formed by combining this P-type and N-type semiconductor. So when you join this P and N-type semiconductor, then its function is start. Then it is called, once you have a PN junction device, then how to apply the voltage to this. So based on this, we have three types of biasing. It is called zero bias. Zero bias means no external voltage is applied to the PN junction diode. Reverse bias is, when a P-type semiconductor is getting a negative, this one, and N-type material is connected to the positive terminal of the battery, then it is called the reverse biasing. And in forward bias, when a positive terminal of the battery is connected to the P-type and negative terminal of the battery is connected to the N-type, then it is called forward bias. And please remember, this semiconductor works only in the forward bias condition. In the reverse bias, it just acts like an insulator. In the forward bias, it acts like a conductor. Okay? And then again, something to know about its breakdown. Because sometimes, when you apply excess of voltage, to the devices, semiconductor devices, then there is a called breakdown. So we have two types of breakdown in PN junction, that is about you are going to study about. One is called Zener breakdown and another is called avalanche breakdown. This is also you are going to study in this one. Then one of the important application of the semiconductors which you are going to study here, that is called rectification. Process of converting AC into DC is called rectification. This is one of the most important application in the electronic field. So almost all electronic devices works on DC voltages, but available voltage for us is AC. So how to convert AC into DC, how to use these are about the rectification, types of rectification. The first one is half-wave rectifier. As the name itself, it implies that, half-wave rectifier is a circuit which rectification is taking place only in one half of the AC signal. Means maybe it is a positive half-wave rectifier or it may be a negative rectifier. That means it is only in one direction. So this is you are going to study. And what is full-wave rectifier? A full-wave rectifier is a rectifier which has both the cycle, it is the rectification takes place. That means, it is continuous in nature. So the AC signal, when it is given to this rectifier, at the output you are getting a DC signal, constant DC signal. So it is another type of rectifier we use. And the last type of rectifier we use is called a bridge rectifier. The one difference between a full wave rectifier and a bridge rectifier is full wave rectifier uses 2 diodes, bridge rectifier uses 4 diodes. So the first half part of the unit 2 is about up to this rectifier, because up to rectifier, what is semiconductor, what are its properties, how the N-type and P-type is formed, and what is biasing, what is PN junction device, and what about the application of the semiconductors or diodes is about the rectification, half wave rectification, full wave rectification, and bridge rectification. So this much, we are going to study in the half of in the unit 2. Okay, thank you.